Hello, in this tutorial I'm going to show you how to go through the demonstration of the inverter, which is in the PDF online. So first I just want to make sure that my license file is correct since I'm on the virtual machine, and to do that I will go cd home and then vim.bashrc, and then we see that the license file is correct. It's the 27500 one right here, so just make sure this is correct. If you had to change it, you could press A, and then that enters edit mode, and then you could change it, escape, and then you type this to change it. So that's just to make sure the license file is correct. Another thing you'll have to do if you're on virtual machine is to make sure you're connected to Duke's network. If you're on campus, you could just connect to the campus Wi-Fi, but I'm at home right now, so I'm on the Cisco VPN. And there are instructions online for how to set that up if you're off campus. So basically now I'm going to launch the software. So I'm on my desktop right now, but I want to make a directory to do this inverter in. So I'll make a directory called inverter project, and then we'll cd into that. And now I can just type dmgr_ic, and that should launch the Pyxis software. So you'll see I have a bunch of projects in other directories, but we're going to make a new project now. And there's an error here right now because one of the libraries didn't load properly, but it will in my new project when I load it. So when you do this for the first time, you might not see any of these, so that's fine. But right now we're going to make a new project. So you go File, New, Project, and I want the project path to be where I'm in. So actually no. We're going to go inverter project and then press OK. And we could call this project 1. So now we're going to load the technology library. So that's located, if you go to your home Mentor VM1 directory, if you are on the VM image, it's in this area. If you're on the computers in the CAD room, it is in your NetID folder that was created for you. So you go Pyxis SPT. Within there, there's one called IC_reflibs. We're doing the technology libs, generic 13, and you press OK. Now you have to add the standard libraries, and we're also going to load GDK gates. So you go to the same location you were just in. So Pyxis SPT, reflibs, except we're going to go to external libs, and then we're going to take GDK gates. So you see in this case it loaded properly, there's no messages or errors, so it's fine. So let me get rid of these. Well, just pay attention. This is the project that I'm in right now for this tutorial right here. So in the project you see that all the libraries were loaded, and including GDK gates, so they're all here. But now what we're going to do is we're going to make the inverter. So we're going to make a new library, and we're going to call it inverter lib. Okay, and then in that library we're going to make a new cell. So we go new cell, and this is actually going to be the inverter. We'll call it inverter 1 just in case. And now if we open that cell, we want to make a new schematic. So that's the first part of what we do in this tutorial. So we go new schematic, and you just press OK. So if your license file isn't properly loaded, this window will pop up and then close immediately. So that means that you do not have the correct license in your bash file, so you need to go back and follow the instructions that are posted on Sakai to fix that. But it loaded, so it looks like we're good. So I'll just keep this window here and make it bigger. So you'll see this area over here. You can also access this by pressing Control-Shift-I, and this will pop up. So what we want to do first is we want to insert the transistor. So those are in the generic 13 library, and they're under symbols. So we're going to get one NMOS. We'll put that towards the bottom, and then we're going to get one PMOS. Put that up here. We're also going to want the, I believe it is in the sources lib, or perhaps somewhere else. Oh yeah, I think it's in generic. Yeah, it's in the generic lib, which is different than the generic technology. So in generic lib, there is a ground and a VDD that we're going to get here. So here is the VDD. So that one will go to the PMOS one. And then we want ground down here. So now I can press escape, and we're also going to want to put ports in this. So you could get the ports by clicking this button here, and we're going to have an input port here and an output port over here. So this is our input, output. So now we press escape, and then if you press F2, or yeah, just, sorry, in my case, oh, okay. So if you're on your laptop, you might just have to press the function key as well. So that deselects everything, pressing F2. So that's really useful when you want to deselect stuff. So I'm going to drag this down a little bit. Guess not. And then if you want to, so now we're going to, oops. If you click this button, it zooms to your schematic. So we're going to change these names. So you click on the port and you press Q. And now we're going to call this in, and this one out. And then we're going to, if you press W, that'll just bring up the wire tool, which is shown here. And now we're just connecting the nets. So something you'll really want to do too is to change the sizes of the NMOS transistor. So because it's an NMOS and this is a PMOS, we're going to make the NMOS about a little less than half the size. So to do that, you click the NMOS, you press Q, and here we change the width. You could also change the length, but we're just going to change the width in this case, and we're going to make it 0.8 microns. And then if you click somewhere else, you'll see that you could now press OK. And then now you'll see it says 0.8 microns. So you check and save, and it looks like we did everything right. So that's it. That's the schematic. That's how to make the schematic. So now what we want to do is we want to generate a symbol from the schematic so that we could use this cell in a different cell if we want to. So we'll do add generate symbol, and then we're going to click the choose shape and click the buffer one. So it's an inverter, so it won't be a perfect match because the inverter and buffer symbol are a little different, but it's a good shape. Now I'll press OK, and here it is. So this is the symbol now that represents that schematic inside of it, and we have the ports, the in and out. So make sure you check and save that, and it looks like everything is all good. So you always want to make sure you check and save all of this. So now that's it. That's how to make the schematic and the symbol. So what we'll do now is we'll close that window, and if we refresh, we'll see that inside of our inverter cell now there's a schematic and a symbol. So now we want to make the layout. So we right click this and do new layout, and we press OK. So you'll see this window pop up, and then you can just leave the defaults and press OK. So you will get an error message here if you do not have any devices in the schematic. So if you get an error message, just go check your schematic and make sure you have it saved and that there's actually transistors or something inside of it. So I'm going to make this so that we could see both of them, the layout and the schematic at the same time. So you go Setup, Preferences, Default, Left-Right Tiling, press OK. So now we're going to add these components to the layout from the schematic. So we go here and then click on the PMOS, and if you see on the DLA logic, you can click Inst, and now that generated a layout for the PMOS. So we're going to do the same thing for the NMOS. So that's here, and you see they're about half the size. Or the NMOS is smaller than the PMOS because of those sizes that we chose. So that's that, and then we're going to go back to the schematic, and now what we'll do is we'll click the port button, and that will generate the ports. So in the schematic, we have 4 ports, the in, out, VDD, and ground. So if I click port, so you see this, what you see here is the ground port. So it's currently on the poly G layer. It says that because you see this pink square and it says poly G, but we want it to be on metal 1. So to do that, you press the number 4 to go up in metal layers, or 3 to go down. But if you're on poly, that's the lowest one, so you just press 4 so that you go up 1 layer. And we'll just put that there. The next one that we will do is we'll go here, we'll press port. Port. Oh, it's because I have this selected, so I'm going to unselect everything. So now everything's unselected. So F2, and then press port again. So yeah, so you basically want to make sure everything's unselected when you press port. So now this is VDD, so I'm going to go to metal 1, and VDD we'll put at the top of the PMOS device because it's connected up there. The next one is the input, so we'll put that over here, and the last one is the output. And again, we're all doing this on metal 1, so make sure you press 4 and go up a metal layer. So that is it for the ports. So now I can save. And I'm going to, so the next thing that you want to do is you want to make vias to connect the substrates to the right ports and supplies. So the way that we're going to do that, the way that I do it, which is a little different than the tutorial, is to actually just draw a rectangle. So if you go here, there's a tool that says add rectangle, this square. So I clicked add rectangle, and I'm just going to draw kind of the outline of where I want the via to be. It doesn't have to be precise. And so I drew it on metal 1. So make sure you're on metal 1. Again, you could toggle by pressing 3 and 4, and the color should match the metal 1 color. So because these are on the same layer, and I drew it around the port, these layers will merge with each other. So I don't have to stretch this one. Basically, this is all filled with metal 1, so this is fine right here. So what I'm going to do is I'm going to select that, that net, and I want to make a via to an N well because PMOSs are in N wells. So we want the power to also be connected to N wells. So I click on that metal shape, and then I go DLA layout over here. And only if you're on the layout tab will that menu be there. So make sure you click somewhere in this window, and then you can see that menu option here. So let me scroll down, via, fill selected, and it's a PMOS, so we're going to go M1 N well. Press OK. So now we have the via that it's a metal layer, but it's also an N well layer. So this green dotted line is the N well. So if you look at this though, you want the N well to actually be around the whole PMOS device. So what I like to do, if you have a PMOS device, is to draw another rectangle. So go here, add rectangle, and I'll just draw it like this. So right now it's on metal 1. I want to change that, so I'm going to press Q. We see the layer name M1. I'm going to make it N well, so NW. So now, if I unselect it, we see that it's the green dotted line, and this is an N well. And because it's on the outside, it's merged, so now there is a physical connection from the VDD to the body of the PMOS. So you do that and save. So now we're going to do something similar for the NMOS, except we don't need to do that outer rectangle because this whole substrate is on a P substrate. So the NMOS will be connected just by the way that we draw it. And if you don't know what I'm saying, just Google cross-section of NMOS and PMOS transistors and you'll see what I mean. So I'm going to add a rectangle. So like that. And then I go again over here, via, fill selected. We're going to go M1 P sub, because this is a P substrate, that's the body of a NMOS. And there it is. So that's all we need to do for the NMOS device because of the body locations. The other thing we need to do is, the gate here is poly, you see, but then this is metal 1. So we're actually going to draw another via around the input. So it's on metal 1, but now we're going to go via, fill selected, and we're going to go poly M1. Press OK. So now we have a via from M1 to poly. And now we want to route all these connections. So to do that, we're going to go over here and we're going to go route. Actually, there's a different route section. Hold on. Route, so it's in the IC palettes. Scroll down and then you can find route. We're going to go iRoute. This should do it. And then here we are. So it's going to be on M1, but right now, so I could do a few things. So I'm going to connect the nets that are on metal 1 right now. So this one right here, that's the connection from the body of the NWell to the source of it, shown here. Sorry, of the NMOS, not NWell. And then there's this output that's also on metal 1, so we can click that again. And this is actually an issue. You see this kind of small change. I know that this is going to give me a DRC error later, so I'm going to undo that and try again. Alright, so this is my output here. And then the last one we're going to connect is the body of, or the, this connection right here, basically, the source of the PMOS to the VDD. So that's good. And you see here there's no, they're perfectly aligned, so that is fine. And okay, now what we need to do is we're going to run this command, but now we want to go to the poly layer. So you press 3 to go to the poly. And what I first like to do is go and connect the gates to one another. And you see here too, actually, there is a slight, it's not perfectly aligned. So I'm going to undo that. And what I need to do now is I need to move this transistor over a teeny bit. So actually what I'm going to do is I'm going to go run poly. We'll go there. And then what we need to do is we need to make this perfectly overlap. So you click on the NMOS, and I'm going to press M. Now, I think there is probably a better way. To do this. So I just deleted that path. There might be a way to perfectly align these two transistors. So I unselected everything. So I'm going to click on the two transistors. Whoops. I'll just select them here since it's easier to select. And then if I go to the layout, let's see if there is a align tool. Align. There it is. Okay. So we're going to align this. Let's do center. We're going to align the center X to the center X. Okay. To this. Let's see, did it do it? And look at that, perfectly aligned. Okay, so sorry for how long that was, but it is good that they were not perfectly aligned because now you know how to align them. So you can go edit, align, and then if you want to align them to the center X, what you'll have to do is you have to select one object and then you click how you want to align them and then you select the other object. So now that we have done that, I'm going to save. And then now the last step is to connect. We're going to go back to the routing, run, and we want to connect this via to this right here. And this looks good. Let's see, I kind of want to have it more towards the middle. Let's see if that's possible or if it automatically, so it looks like it automatically chooses which side, so I could just take this whole thing and shift it myself. Oops. Well, that's not really, let's see. Okay. Not entirely, alright, whatever. It's not that important. Okay. So here we are. The last step that we need to do is we need to, lastly, I'm just going to make sure these are aligned and fine over here. They look good. That looks good. Okay. So lastly, we need to define, oops. Okay. We need to define the nets and the port names. So we're going to do add text on ports. So this is why you want all the ports to be on metal 1, because otherwise they won't be assigned the right net. So we press OK. And now in the LVS, if you have any issues, it's most likely with this step. So you see that it added the text onto all of our ports. So without those, there's no way that the software knows which nets should be what. So, but this is good, and then that's it. That's pretty much our layout. So what we can do now is test if it worked. So we're going to go Tools, Caliber, and first we're going to run the design rule check. So that's the DRC. So you don't have to change any options. You could just click Run DRC. So this will check to make sure that you have all the Foundry specific rules, like the minimum length to everything and etc. So it's mostly just about the shapes and the rules, nothing to do with connectivity. And so you see there's a lot of ones I got right, but I want to just see the ones I got wrong, so I'll click Show Unresolved. And there's only one, and this is the one that's fine to just have. It's called the polydensity error, basically, and it's just talking about the minimum polydensity. So this is like when you actually go make the chip, this is an important thing, but for the sake of our class, we don't need to worry about this. So if you ever want to prove to me that you've done it and you got DRC correct, you just take a screenshot of this, and now we'll X out. So we passed DRC, and now we want to do LVS. So Tools, Caliber, Run LVS. And it's perfectly possible to get, to get DRC but not LVS, and the same way, vice versa. So it's important to check both. So we're going to go to the Setup LVS options, PowerNet, VDD, and GroundNet, ground. And now we can run the LVS. So look at that, you'll see a smiley face if everything worked out. And in the LVS report, you could see that there are the same number of ports, nets, instances in the layout and the source. So if you ever, have an issue and you don't see the smiley face, you should scroll down here and look at the differences between them. So, if you had too many ports in your layout, maybe it's because you didn't connect a net somewhere. And yeah, so if you ever have any issues, and you'll see that down here, it shows that these are the ports that it detected in the layout. So that's good. So yeah, and then this would tell you more information. So if you have any issues, you should just take screenshots of this and try to figure it out. Or email me, or post on the EdTech forum. So that is the LVS. So the last thing I will show you is how to simulate the schematic. I will make another tutorial for how to extract the parasitics and simulate that. So we're going to just refresh this. So here's the layout now. So now what we're going to do is we're actually going to make a new cell in the inverter library. So we're going to go up one, inverter library, go File, New Cell, and we're going to call it Test Inverter 1. So we're going to open up that thing, and we're going to make a new schematic. New schematic. Just okay. So in here, we will see that we can always have the same options thing. If you want to make this pop up, you press Control-Shift-I, or you just press I and it'll pop up. And now we're going to go to project 1, and inside of there, there's the inverter library. And if you look at that, there's actually a symbol here that we just generated. So it's the inverter 1. So we're going to place that in our schematic here. So that's an instance of our inverter. So now what we're going to do is we're going to add ports to this schematic. So we'll have one here, and then we're going to have an output over here, and then we're going to W wire these up, and now we want to call this, we're going to call it test out, and we'll call this one test in. Now I press save. So another thing that we need to do is to add the actual stimuli that we're going to apply to the system. So to do that, we go over here, we're going to go to the sources library. The first one we'll have is we're going to have two DC voltage sources to define the ground and the VDD. And then the last one we'll have a pulse voltage source to define the input. So it's pulse V source. And then we're going to need to go back to the generic library, and we're going to get the VDD. And we're also going to get VSS. So we didn't define the port of ground to be VSS in the inverter, but often there are global nets such as VSS, and if you're using a process where you have split power supply, so maybe plus or minus 2.5 volts or something, the VSS would be the lower voltage, whereas ground is actually 0. So you probably don't need to do this step for this inverter, but I'm just going to show it to you now in this schematic. To rotate it, I just pressed R. And then, we also need ground. Okay. So now we're going to wire everything up. The pulse will connect to the input, so I'll add that net. And then they'll all have the same ground. And now we want to define them. So the VSS is going to be 0. That's our lowest voltage. The VDD, let's make it 5 volts. And the pulse, and to edit this, you just click on the object and press Q. So the pulse, we're going to make, you could leave all the default settings, make sure you make the delay 0 microseconds. And now we're going to make the pulse value 5 volts. And then we press OK. So now everything is set up for us to simulate. You check and save. Well, it looks like we're good. And now to launch the simulation, you come over here and you press the play button. And we're going to add a new design configuration, default, press OK. And here we are, we're in simulation mode. You can tell we are by this stop sign, it means exit simulation mode, so that means we're in it. So now we're going to edit the simulation setup. So you come up here and you click on this button that says Setup Simulation, and then we're going to do just a transient simulation, and we're going to do 1,000 nanoseconds. And then we press OK and run. And it looks like it ran. So you can see that down here. So to actually see our results, we have to click this button, and we're going to click Easy Waves. So view Easy Waves. Normally this is a little, yeah, we could have this yellow. So Easy Wave is usually over here. So we'll click that button, and now we can see the plots. So that's the results from our latest simulation. We have a transient simulation, which is what we selected. The input, that's the pulse that we made, and then the output, let's put it down here. Let's make this all bigger. And look at that, we see we have an inverter. So if you want to zoom in, you just kind of drag, And you see that when this input is high, the output is low. And you'll see that, you know, it's not a perfect inverter. So for example, this one goes high, but then it takes some time before it goes low. So, oh, whoops. So this button will zoom out. So these are the kinds of things that you might need to look at during your homeworks or labs in the future or your project. So that summarizes our tutorial on how to go through the online inverter creation for VM Pyxis. It also works on the computers in the lab. And like I said, I'll make another video for the parasitic extraction and simulation. Thanks.